Hello again. We are continuing our discussion on linear equations by talking about parallel and perpendicular lines. So let's get started. Let's say I wanted to write an equation of a line that is parallel to a given line and passes through a given point. Well, here's how I'm going to do that. First of all, let me explain that lines are parallel if they do not cross, and they will not cross if they have exactly the same slope or steepness. So whatever the slope of the original line is, I'm going to use that exact same slope for the new line, and I'm going to call it m. Since I was given a point, I'm going to call that point x1 and y1, and I can plug those three things into point slope form because those are the three things that point slope form requires. There is point slope form, and the numbers y1, m, and x1 will be replaced with those numbers that I found in the earlier steps. If it needs to be written in some other form, then I'm going to make any changes that I need to make. Use distributive property to get rid of parentheses, for example, add or subtract things from both sides, multiply, divide both sides by something, whatever I need to do to get from one form of a linear equation to another. So here's an example. I need to write an equation in slope-intercept form for the line that passes through 8, 3 and is parallel to y equals 2x plus 1. So I'm looking at y equals 2x plus 1, and the slope of that line is 2. So any line that is parallel to y equals 2x plus 1 is also going to have a slope of 2, so I know that my slope is 2. I've been given the point 8 and 3, so that's going to be my x1 and my y1. So I plug all of those into point slope form, which is given to me right there. And what it will look like is y minus 3 equals 2 times x minus 8. Okay, that's point slope form. But I was asked for slope-intercept form. So I need to make some changes. The first thing I'm going to do is get rid of the parentheses by multiplying out that 2 using distributive property. So 2 times x minus 8 is going to become 2x minus 16, and the y minus 3 can stay as it is. It almost looks like slope-intercept form except for that minus 3 that's on the left along with that y. So to get rid of that minus 3, I add 3 to both sides, and that's what it's going to look like. The minus 3 and the plus 3 on the left are going to cancel out, and the minus 16 and the plus 3 on the right are going to simplify to be minus 13. So my equation is y equals 2x minus 13. That is parallel to y equals 2x plus 1 because it has a slope of 2, and it is going to pass through the point 8, 3. So I've found the correct line. Now let's talk about perpendicular lines because those are a little tougher. They don't have the same slope, and in fact their slopes are related, and we'll figure out how they're related. So there's just some random line that I've drawn, and I need to draw another line that's perpendicular to it. Perpendicular means that they will cross at a 90-degree angle. Okay, so I looked at this green line and I figured out the slope. The slope of this line is 2/3. Okay, so if I draw a perpendicular line somewhere on the same graph, I need to know what slope that has. It's not going to be 2/3, but it's going to be something related. Okay, so let's pick any 2 points and figure out what the slope is between them. Well, if I want to get from one of those purple points to the other one, then I need to go down 3 spaces, so my change in y is -3, and I need to go right 2 spaces, so my change in x is 2. That means my slope is change in y over change in x, which is -3/2. So the purple line has a slope of -3/2, and the original green line has a slope of +2/3. So maybe you can see what the relationship is, but just in case you can't, let's go through some more examples of slopes that are perpendicular to each other. Okay, so here's some slopes of lines that are perpendicular. Okay, so a line with slope 3 is perpendicular to a line with slope -1/3. A line with slope -6/7 is perpendicular to a line with slope 7/6. A line with slope 4/11 is perpendicular to a line with slope -11/4. A line with slope -3/5 is perpendicular to a line with slope 5/3. And so what is the pattern that we see? First of all, I notice that the slopes have opposite signs. One of them is positive and one of them is negative every time. Okay. Also, I notice that the fractions are flips of each other or reciprocals of each other. They're flipped upside down. Even that 3 at the very beginning, remember 3 can also be written as 3/1, and that gets flipped upside down to make 1/3, which then becomes negative to make it perpendicular. So that's how I find the slope of a perpendicular line. I take the slope that I was given, change the sign of it, and flip the fraction upside down. So if I had a line that had slope negative 2/13, then the perpendicular line to it, or any perpendicular line to it, would have a slope of 13/2. Okay, so that's going to help us find our m. It's a little bit more work, but once we get that new slope, it's going to be the same amount of work after that. Okay, so if I want to write the equation of a perpendicular line through a given point, I look at the slope I was given and I find what's called now the opposite reciprocal. Change the sign and flip it, and that's going to be my new m. I'm still going to use the point I was given because it does have to pass through that point, and I'm going to plug those three things into point slope form, which is given again right there. And if it does need to be written in some other form, I'm going to make the changes by distributive property, adding or subtracting to both sides, and so on. So here's an example. I need the equation of a line in standard form, and it passes through 10 and 4, and it's perpendicular to y equals 2x plus 1. Okay, so the line that I was given had slope 2. So the perpendicular line is not going to have slope 2. I need to change the sign of it, and I need to flip it upside down. So changing the sign makes it negative, and flipping 2 over 1 upside down makes it 1 over 2. Okay, the point I was given is 10 and 4, so that's the point I'm going to use, along with that slope of negative 1/2, plugging them into point slope form so that it will become y minus 4 equals negative 1/2 times x minus 10. Okay, that is point slope form. I need standard form, so I've got to make some changes. Distributive property comes first. So that negative 1/2 on the right is going to be multiplied by those parentheses, x minus 10, so that the negative 1/2 times x is negative 1/2 x, and the negative 1/2 times negative 10 is positive 5. So I have y minus 4 equals negative 1/2 x plus 5. All right, so now what I'm going to do is I'm going to add 4 to both sides so that it looks like this. And the negative 4 and the positive 4 on the left are going to cancel out, and the positive 4 and the positive 5 on the right are going to simplify to be 9. So I have y equals negative 1/2 x plus 9. Okay, so standard form means I need to get the x's on the left now, so I will add a 1/2 x to both sides. And if I do that, it looks like this. 1/2 x plus y equals 1/2 x plus negative 1/2 x plus 9. So now it's the 1/2 x and the negative 1/2 x that cancel each other out. And so I get 1/2 x plus y equals 9. It's almost in standard form, but remember I'm not allowed to have any fractions, so I will, since 1/2 is the only fraction I have, I will multiply both sides of this equation by 2. So a 1/2 x times 2 will be just x, 2 times y will be 2y, and 2 times 9 will be 18. So my final equation in standard form is x plus 2y equals 18. That is perpendicular to y equals 2x plus 1, and it does pass through the point 10, 4, so I know that I have found the correct line. Okay, so that's how you find equations of parallel and perpendicular lines. If you have any questions, please let me know, and I will see you tomorrow.